Welcome to the Crazy Hat Chemist. So today we're doing another video here. So let's get started. Bam! Today we're talking about successive ionization energies. So that is sequential, one right after the other. So you should see this chart right over here. On the top of it, I have the elements. Okay, so I have sodium, magnesium, aluminum, silicon, phosphorus, sulfur, chlorine, and argon. That's on the top. On the far left-hand side, I have ionization energy 1, ionization energy 2, ionization energy 3, 4, 5, 6, and 7. And then you should see this yellow staircase line. And this is going to be very important here. So, here we go. These are ionization energies. These are in kilojoules per mole. And these correlate with the number of valence electrons and the group number that's associated with that element on the periodic table. So I'm going to point this out here for you. We're going to take a look at sodium first of all. So what group is sodium in? Sodium is in group number 1. That's the alkaline metals. Okay, and so since it's in group 1, how many valence electrons does sodium have? 1 valence electron. Therefore, the first ionization energy is a small number. That's 496 kilojoules per mole. After removing that 1 valence electron, what kind of electrons are left on sodium? That's correct. Those are core electrons. So the core electrons are yet remaining. So therefore, it's very difficult to remove the second electron after removing the first. That would be the second ionization energy. And that's why the second ionization energy for sodium is so high at 4,562 kilojoules per mole. So please take a look at your periodic table and look where sodium is. Okay, now we're going to take a look at the next one. Before we do that, sodium does have a 1+ charge. That's the only ion charge of sodium. And notice I've indicated that right there above the Na, and now it's a 1+. Why? Because it's in group number 1. Okay, let's look at the next one there, which is magnesium. Okay, magnesium is in group 2. It's the alkaline earth metals. Okay, so how many valence electrons does magnesium have? It's in group 2. How many valence electrons? 2 valence electrons. Since it has 2 valence electrons, then the first 2 ionization energies are relatively low, increasing but relatively low. So the first ionization energy for magnesium, the first removal of the first electron, is 738 kilojoules per mole. Okay, that's one of the 2 valence electrons. Now, to remove the second valence electron, that costs 1,451 kilojoules per mole. That's the second ionization energy. Now, once you've removed those 2 valence electrons, you have a 2+ charge on magnesium ion. And that should make sense because it's in group 2. There are 2 valence electrons. It has a 2+ cation charge. Metals lose electrons. Now, can you remove any other electrons from magnesium? You can, but it costs a great deal of energy, and that would be 7,733 kilojoules per mole. Therefore, there's this enormous jump between the second and third ionization energies for magnesium, or anything in group number 2 would follow this same pattern. Okay, so let's do another one here. This next one is for aluminum. Okay, now take a look at where aluminum is. Okay, hopefully you've done the electron configuration for aluminum. It's the outer valence electrons are 3. Okay, that's why it's a 3s2 3p1. Okay, so the first ionization energy for aluminum is 578 kilojoules per mole. After that, the second ionization energy is 1,817 kilojoules per mole. The third ionization energy is 2,745 kilojoules per mole. And you get an aluminum ion that's a 3+ charge because you have removed the 3 outermost electrons. Furthermore, I'm going to add to this here in that you should see that those ionization energies increase as each subsequent electron is being removed, and that's because the effective nuclear charge is increasing. That is, you're decreasing the number of electrons, but the number of protons in the nucleus has remained unchanged. So therefore, there's a greater attraction to those electrons to hold them on to that atom or ion as the effective nuclear charge increases. Now, the fourth electron, which is a core electron for aluminum, what does that cost? 11,575 kilojoules per mole. Again, that's totally impractical, and that won't be done because aluminum will not remove core electrons. Aluminum has only two charges, and that is a zero charge for aluminum metal, or it's a single cation charge of a 3+ charge. These charges are also called the oxidation numbers here, and that's going to be coming into play with another unit. But eventually you're going to get to know the oxidation numbers, and what's so important about the oxidation numbers is that, well, this is how we get those oxidation numbers. Okay, so I want you to look at silicon and phosphorus and sulfur and chlorine and argon. Now, as you increase, you're looking at 4, 5, 6, 7 valence electrons. It becomes increasingly difficult to remove electrons. That is, the ionization energy is becoming more and more difficult as you go to the right across a period. Okay. Furthermore, as you look at these with the 4, 5, 6, and 7 valence electrons, it costs more and more energy to remove each subsequent electron. Now, as you look at chlorine, chlorine is a nonmetal. Nonmetals don't like to lose electrons anyways, and that's why its first ionization energy of 1,251 is already very high. Okay, and each subsequent one is very high as well. In fact, chlorine would like to gain electrons instead of losing electrons. That's why it's far over there. And of course, argon doesn't want to gain or lose electrons. Okay, those are successive ionization energies. You should understand where the big gigantic gap or the bridge between the core and valence electrons are, and you should be able to describe that. You should also understand that there's an increase in ionization energies as you remove electrons because the effective nuclear charge has increased. Okay, hopefully you enjoyed that video. Give me a thumbs up if you like that video. Please subscribe to my YouTube channel and pass on the word if you know of anybody else that needs chemistry help. All right, thank you very much. Have a fantastic day and look forward to having next videos on periodicity. I'll see you next time. Bye now.